Hi, I'm Paul Woods, Chief Innovation Officer at Global Fishing Watch, and I'm going to tell you a little bit about us and about the Open Ocean Project. And I have some slides, so here we go. Oops. Go. There we go. Are we good with the slides? Yep. Okay. So the Open Ocean Project. This is a project that we launched out of Global Fishing Watch thanks to funding from the TED Audacious Prize. So I'll tell you a little bit about who Global Fishing Watch is first. So we're a 501c3, a nonprofit. We're US based. We have a global staff. We started the project in 2015 when I was the CTO at SkyTruth. The project was formed with three partners, SkyTruth, Oceana, and Google in 2015. In 2017, we stood up an independent organization. I was the interim CEO, and we attracted somebody who's better at raising money than me. I've been focusing on the tech vision ever since. We're now about 120 people in 30 countries around the world. We focus on research, technology development, and public policies, especially in fisheries, promoting conservation and better ocean management. And so we've launched the Open Nation. Let's see. So in 2023, we received the TED Audacious Award, and with the proposition that we would map all human activity at sea. This is a 5-year project that we're in the middle of, and that's what we're going to tell you about now. Sort of what we're doing there, what the capabilities are, and what might be interesting to all of you. So the Open Ocean Project. So this, what you see behind there, that's the artist rendition that we used in the TED Talk that launched this project, being able to see all industrial activity at sea on a map in real time. So what are we going to do specifically? We said we'd map all human activity at sea. All has an asterisk there, of course. We're not tracking recreational fishing per se, not humans on the beach, but this is really industrial and commercial activity in the ocean. Also all the offshore structures. When you have to map all the boats, you also have to map all of the structures and pretty much everything in the ocean in order to detect all the activities. Our goal is to try to cover all major industrial uses of the ocean. I'll tell you about what some of those are. The mission is to provide free and open data for better open management. That means all of the data we produce, we give away for free on our mapping tools and APIs on the internet. We produce custom tools for visualizing and analyzing all this data, which are open and free for people to use. A key part of our mission is establishing a common set of facts for all parties to be able to participate effectively in global ocean management, which is especially important as the high seas begins to come under management with the new UN negotiations for the BBNJ, Biodiversity Beyond National Jurisdiction Management Framework. Major industries, offshore oil has been a major ocean industry for a long time. Fishing, of course, has been a industrial activity in the ocean for all time, more or less. Offshore wind, rapidly growing. We're mapping all of the wind infrastructure. Mining, coastal mining for aggregates, seabed mining for minerals for batteries, aquaculture, and then shipping, of course. So all of those we are now or in the progress of tracking, mapping, and making that data available. So this is kind of a list of what we're doing. You don't need to memorize this list, but so we have industrial fishing, small scale fishing. That's what Global Fishing Watch does. That's our core. Marine oil production, working with SkyTruth, marine wind power. A bunch of partners now interested in helping to accelerate the development of offshore wind. Some others, climate, we have several climate initiatives with partners looking at emissions from vessels as well as emissions from blue carbon stores that are caused by human activity. We're also interested in aquaculture and even small-scale non-fishing, so recreational fishing. We don't have any partners there yet, but we do have a research project now that's looking at mapping that. So the timeline of this thing, so like I said, we're funded by the TED Audacious Prize. We're in year 2 of 5 for the R&D of this thing. We're releasing new capabilities as we go, pushing them. We already have the mapping platforms. We're pushing data out as it's available. And then we are contemplating the launch of something we'll call the Open Ocean Platform, where we'll bring all of these different views of the industrial use of the ocean together in one data platform. Planned for 2027. That'll be our 10th anniversary, so that'll be kind of nice if we get there. We have a lot of work between here and there, and we're also looking to develop from 2027 on a sustainable funding model, because the TED Audacious Prize is a big pile of philanthropic money and it doesn't repeat. So we need to figure out how we support this thing ongoing. Stakeholders in the project include mostly philanthropy right now in terms of funding. TED Audacious, Bloomberg, OceanKind are two of our biggest funders. We also have some of our funding directly from governments. The government of Canada is notable for funding a lot of our activities around the world. Our partners are NGOs, scientific laboratories that work with our data and help us develop machine learning models to process all our data, working with governments across the developing world, as well as US, Canada, EU, and Japan, and at the UN level with the FAO and IUCN and others. Lots of acronym agencies there. And then the users of our platform, the governments around the world, we're providing data support, capacity building to governments for fisheries, so they can use all this data to more effectively manage marine protected areas as well as fisheries in their EEZs, foreign fleets, illegal fishing, and everything else that goes on. Once you start to manage fishing, you kind of have to manage everything that goes on in the water. So NGOs, wide range of partners and others that use our data for ocean conservation, researchers, industry. We're actually engaging now with industry and seafood supply chain, insurance for vessels, and ocean infrastructure. So people that have infrastructure on the bottom of the ocean are interested in the data about what's going on the surface, as we've learned with the recent Baltic Sea cuts and cables and other things. So that's a very promising area of work for us. The underlying technology. So I'll just do a real quick primer here. Many of you already know all this, so you can check your email while I'm talking. Vessel tracking. Oh wait, is this? You're probably seeing this thing. Sorry, vessel tracking and navigation. There are GPS transponders on many vessels. AIS is the primary technology. VMS is another technology. We gather that data with terrestrial receivers or satellites, and that lets us make detailed tracks of the movements of vessels. From the movements, we get behaviors, and then we can map all the behaviors. And then we have satellite imaging is the other way we get at stuff. So directly detecting boats on the water. That lets us detect all the ones that are not broadcasting, which includes the ones that are doing illegal things. So that lets us map what we call the dark fleet. That is the non-trackable fleet. And then we put that all together in remote sensing data fusion. So we use infrared from satellites, we use radar from satellites, we use optical from satellites, and then we merge all that together into a unified picture of what's going on in the water. And this produces a daily product that maps much of the ocean daily. And our goal is to get to all activity in the ocean daily mapped. So then when you start to look at it, this is what it looks like. So this is a map of vessel activity interacting with offshore structures in the North Sea, supporting oil platforms, interacting with wind vessels, interacting with wind infrastructure, where all the fishing is and where all the non-fishing shipping is. So you can start to get a really robust picture and then move through this in high temporal resolution. And so one of the things that it does for fisheries is you can see all of the dark fishing. So this is the Mediterranean, a couple of spots in the Mediterranean where you can see all the blue stuff is the stuff that can be tracked. with GPS trackers, and then all the orange stuff is stuff that can't be, that we can detect from satellite. So we can map where the unmanaged, untracked fishing fleets are, provide that to governments, and help them to put in place better tracking systems, including mandating GPS tracking, which makes things a lot easier. So we're working directly with governments like the government of Tunisia there to help them understand the fishing. Of course, this also speaks to other vessel activity like human trafficking and other things that happens in similar boats to the fishing boats across the Mediterranean. Some gaps in the technology that we have right now: we don't really see small vessels very well. We use 10-meter optical imagery, and the small vessels don't have trackers on them. So that's a problem for us, and I'll tell you what we're doing to work on that. Beneficial ownership is also a challenge, particularly for fishing vessels. So even if you can identify a boat, you don't really know who owns it and who's benefiting from the activity. This is an ongoing challenge globally to make ownership more transparent, and we think that's important for effective ocean management. And then ocean environmental sensors: we'd love to have a lot more information about the ocean environment, particularly below the surface. That's really hard to get at right now at scale. We do everything at global scale, which is efficient, but we really need to figure out how to get better at aggregating ocean environmental data. So to get at small vessels, we've just done a deal with Planet Labs. We're buying 3-meter optical imagery from them. This is kind of what you can see. So we see all the dots are small boats, and the ones with the wake are the ones that are moving quickly enough. So we're using this to detect all the small boats that we can see. This will get us down to boats about 9 meters. Right now we can see boats at about 15 meters reliably. We are doing the entire global coastline with this project. So we will be able to get 2 million square kilometers of cloud-free 3-meter optical imagery every day, which will be well over a petabyte after we accumulate a year of it. And so we will do the coastline. We don't do everywhere every day because of clouds primarily, but we're going to try to do all the coastlines out to 15 kilometers. And this will get us all the small boats. It also is going to give us all the structures and all the other things that are visible in that imagery, which is not fishing, and we'll have to figure out what we're going to do with that once we have it. We're also using Planet's SkySat high sub-meter resolution imagery to map all of the ports, the anchorages actually. So we've mapped everywhere boats go, whether there's a designated port there or not. And then we're imaging that with high resolution imagery. That looks like this. And then building models to automatically detect and count all the boats. And again, we're going to see a lot of structures as well, a lot of interesting things that we're going to have to figure out what they're good for. Some future technologies that we would love to explore, but we're not doing right now: shore-based cameras, and as well as shore-based drones that see things at high resolution are very interesting. And also we're looking at social media. So we're doing a small project with recreational fishing in the Gulf of Mexico, where we have access to some social media data where people are posting pictures of their fish, and you can geolocate those pictures, and then we're correlating that to the satellite stuff to see if how well we can help NOAA map where all the activity actually is in the Gulf of Mexico. If that works there, then we'll try to extend it to other parts of the world. So in fisheries, we're working with partner governments. We're monitoring 30 million square kilometers of ocean in one way or another across 4 regions. We review and monitor about 25,000 individual vessels with government partners to determine if their activities are legal and regulated, and then that leads to enforcement actions, sanctions, and vessel impoundment, and even criminal penalties for the vessel operators. We're contributing to better implementation of the Port State Measures Agreement in 15 countries now, and reviewing. We're providing a tool as well as analytics review for vessels entering ports, which is far and away the best place to conduct maritime enforcement. Much cheaper getting them in port than chasing them around on the water. And then we're active now in 10 countries and 5 regions around the world. We work with 30 ocean fisheries and environment ministries in fisheries specifically, and 300 government officials that are collaborating directly with us. So that's sort of the scope of our global footprint. Now, I'll just mention a couple of opportunities. These are things we'd like to see if anybody here wants to talk about with us. We're looking for partners to partner with us in our what we call our enabled impacts. So there's all the non-fishing impact areas. So wind, oil, mining, seabed infrastructure, everything. And of course, we work, SkyTruth is our premier main partner for oil, and Jason's going to tell you about that in a minute. And then other technology that we're not using but should be, that we're also very interested in that. In the longer term, we're interested in ideas and business models for long-term sustainability of the platform. We've learned, of course, that giving away for things for free on the internet is not really a great business model. So we're going to need to develop better ones. But right now we have the luxury of large-scale philanthropy, so we can. So we're going to do it. Give it away for free as long as we can, and then figure out how to make all this technology sustainable in the long run. So with that, I think I should hand it over to Jason, who's going to tell you about what they're doing with oil on the surface of the water. All you, Jason.
All right. Thanks, Paul. Okay. Hey, everybody. I'm Jason Schatz, CTO of SkyTruth, and I'm going to talk today about our work on the Open Ocean project. Let's see. There we go. So a couple of things I want to cover: SkyTruth and a little bit about our history, our specific role in Open Ocean. That'll lead into some of the oil pollution monitoring work that Paul just mentioned. And I want to talk about some of our future plans around cataloging risks for tankers, cargo ships, offshore oil platforms, and a few other things in the oceans. So a little bit about SkyTruth. We're a nonprofit that's been using satellite data to track environmental change for almost 25 years now. And specifically, what we do is build conservation technology. So in practical terms, that means we provide data, software, and custom analyses to support the conservation community and to mostly accelerate campaigns for environmental protection. And similar to Global Fishing Watch, everything we build, we give away for free. We're funded by philanthropic organizations to make an impact. So that means for us making data and insights as accessible as we possibly can. And here's some examples of the work we do. It ranges from monitoring industrial impacts on the ocean to biodiversity protection on land to a lot of stuff in between. So very wide range of issues, and they have a couple things in common. So first, we tend to seek out issues that are overlooked or under-resourced. And second, we look for things where there's an opportunity to advance them using Earth observation data and satellite imagery, which is what SkyTruth specializes in. We don't think anybody should need expertise, time, or money to know what's happening in the world around them. So we try to bridge that gap using satellite data to make environmental issues very visible and accessible. And that's very much in the spirit of Open Ocean, which, as Paul described, is Global Fishing Watch's program to map and monitor all human activity at sea. And yeah, for Open Ocean, you saw that long list of things from Paul about all the aspects of ocean activity that are going to be monitored. And where SkyTruth has focused most of our energy so far is monitoring industrial pollution, mainly from fossil fuel extraction and transport. So we're building tools to track oil pollution, monitor vessel activity, catalog offshore oil platform impacts and risks, and various other related activities all over the ocean. And for a little bit of history on that, SkyTruth's been working on issues like this for quite a while. So our first big foray into ocean monitoring was way back in 2010 when the Deepwater Horizon rig exploded off the coast of Louisiana. The explosion killed 11 people. Oil started pouring into the Gulf of Mexico, and it's easy to forget now, but for quite a while, no one really knew how much oil was being spilled. Official estimates at the time from the Coast Guard and from British Petroleum were around 1,000 barrels per day, but SkyTruth used satellite imagery to actually check that out. So we estimated a flow rate between 5 and 20,000 barrels per day. The official estimates were corrected based on that, which was important because the size of the fine that BP had to pay was directly proportional to the size of the spill, and that ended up putting billions of dollars into the hands of affected communities. So ocean pollution's been on our minds for a long time now, and not just for catastrophic spills like Deepwater Horizon, but Also, the ordinary everyday oil pollution doesn't grab headlines, but that happens thousands of times all over the world every year. So honestly, there are parts of the ocean where you really can't look at a satellite image without seeing oil slicks on the water. And this is a problem that we call chronic oil pollution. And for chronic oil pollution, these are generally smaller slicks that come from two main sources. The first one is vessels dumping oily bilge wastes, and the second is offshore oil platforms dumping oily wastewater into the sea. And both of those things create slicks like you see on this slide. So individually, these slicks tend to be pretty small compared to something like Deepwater Horizon or Exxon Valdez. These are typically tens of kilometers long, maybe 100 or up to a few hundred barrels of oil per slick, but they're so common that if you add them all together, they add up to a really massive amount of pollution entering the oceans. It's kind of a death by a thousand cuts. And to give you a sense of how big the problem is, a 2022 study found that these types of chronic oil pollution events cover country-sized areas each year. And if you do some quick math, this adds up to more oil from these small-scale chronic events than was spilled from a lot of the big catastrophic spills you've probably heard of. So we've been wanting to do something about this for a long time, and recently we built a global marine oil pollution monitoring system that we called Cerulean. So Cerulean's completely free and open. You can check it out using that link in the bottom right. And Cerulean fundamentally uses computer vision to scan thousands of satellite images every day to detect oil slicks and their sources. So on the left, those yellow dots that you see are potential oil slicks that we detected last year. And the zoomed in view on the right, you can see the Persian Gulf, where some of those slick detections are resolving into the characteristic long, narrow streaks that are pretty common with these types of oil slicks. And you'll see similar patterns in the Mediterranean, Southeast Asia, the North Sea, all over the world. And one quick thing that's important to note if you check out Cerulean is that not all of these detections are actually oil slicks. There are a fair number of lookalikes on the ocean caused by weather and other events that confuse the model. So it's important to verify any given slick detection, but a lot of these are real, which gives a sense of how pervasive this issue continues to be. But detecting oil is only half of what we're trying to do. So once we detect a slick, we compare its location and timing to the trajectory of vessels and the location of offshore oil platforms using data from Global Fishing Watch. So we can identify not just the fact that there's oil pollution occurring, but also who's responsible for it. So in this slide, you can see an example off the coast of Spain. So to get you oriented a little bit, that dark streak from left to right is an oil slick. That white dot, if you can see it at the tip of the oil slick, is a vessel, and that red arrow that's flashing on and off is a vessel track from AIS ship position data. So what our system does is, again, automatically identifies the oil slick, then it identifies the vessels that are most likely to be associated with each one of them. And in this case, we were able to trace it back to a specific vessel from China. We don't know just from this data alone whether this is illegal bilge dumping or maybe tank washing of palm oil, but with this information, we can identify use cases that we can investigate a little more deeply. And we're doing the same thing for offshore infrastructure too. So using the database of offshore oil and gas infrastructure that Global Fishing Watch hosts, we compare oil slick locations with infrastructure locations and can identify when, where, and how much oil they're putting into the ocean. And these are all, to give you a peek into the future, these are all incremental steps toward our bigger goal of really turning the focus from individual pollution events that we've been identifying for a while now to the polluters who are responsible for them. So this year, hopefully in the next couple of quarters, we plan to release these comprehensive polluter profiles that really put the spotlight on vessels and offshore oil platforms. So their pollution histories, their history of AIS use and misuse, which ports they visited and which countries may be interested in what they're doing, which flag states they hail from, and eventually who owns them. So this is some of the beneficial ownership data that Paul was referencing earlier. And at the moment, we're working closely with Global Fishing Watch to create the building blocks of the system. And yeah, we're really excited to put this out into the world later in 2025. And we have a lot of other big plans and work streams underway, so stay tuned for a lot more in the coming months and years. Cerulean in particular is in very active development. We're rolling out new features every few weeks. So if you're interested in exploring our data or giving us feedback or exploring how we could collaborate, check out our platform at cerulean.skytruth.org. And we also have an API if you're a data scientist and want to start playing with some of the raw data. Feel free to get in touch with us if you have questions about that. So thanks very much for now, and looking forward to questions and some good discussion later.